Why don't we kick it off, Ben? We'll get into it, and people can listen back if they come in late. I'll hand it straight over to you.
Sounds good. Thank you, Xavier. I guess the purpose of this space is just to kind of answer some questions and talk about what's coming up for Gensyn. So hopefully everybody saw the tweets recently from me and from Harry as well on the TG announcement and the kind of products and the tech that we're building ahead of April. So we're really excited about what's happening in April and what we've got building behind the scenes. I'll run through kind of the high level, basically what we said in those tweets, and then can kind of address any questions and things, and we can go into more detail as and when it makes sense. I guess the first thing to mention straight up is what is happening in April. So I mentioned this in the tweet thread, but we're launching two specific things. Three, I guess, if you count the kind of chain itself, the mainnet, the TGE, etc. But the two main products that we're launching are which is a reproducible execution environment for AI on heterogeneous hardware. This is a pretty low-level primitive for machine learning to be done fully deterministically on multiple devices. So you could have an NVIDIA GPU and you could execute a machine learning model. You could kind of use an LLM, ask it a question or something like that. And then you could run the exact same thing on another device. It could be another NVIDIA device, or it could even be an AMD device or a kind of Intel CPU. And you would get absolutely exactly the same output down to being able to hash the execution itself and get an identical hash. This is kind of a pretty low level primitive at the machine learning level, but it enables an enormous amount of things. And so we're using it in the first application, the kind of higher level consumer facing app that we launched, but it's also useful in tons of different places. And people will have heard us talk about the different use cases of reproducible execution in the past, no doubt. It unlocks things like compute, outsourced execution of compute. So using somebody else's GPU as a kind of node to execute a task that you couldn't do yourself. It allows you to do verifiable execution to judge kind of subjective scenarios. So you can use an LLM model to decide something. You could commit to a contract that will be arbitrated by an LLM judge in the future. So if you were kind of signing a contract with another human, you could actually just both commit and agree to a set of natural language that will be arbitrated in the future by an LLM model. And when that actually happens, you would be able to re-execute the model and know for sure that it was done correctly. You would kind of have committed to this intelligence which is going to subjectively assess a scenario, and that intelligence will execute fully deterministically, which you can't have from a human, right? Like we kind of trust human judges, but they ultimately aren't really verifiable. We have to just kind of believe in the biases that happen there. With AI, we get the access to the intelligence, but you also get that kind of determinism and ability to go deep into what's actually being decided. You can kind of inspect everything using the compiler that sits underneath Re. So that's a pretty low-level machine learning primitive. The other thing we're going to ship is an application. That application is Delphi. Delphi exists right now on testnet, but in a different form. So the form that you see on testnet right now is a kind of form of machine learning model arena. Machine learning models are able to compete against benchmarks. When they kind of run those benchmarks, everybody can see their performance on those benchmarks, and anybody in the world is able to predict what they think is going to happen out at the end of that arena. So if those models are going to run like 10 different benchmarks, you can predict which one you think will win overall. And as the benchmarks are released, you can change your answer, you can interact with the prediction market, and you can essentially inject information into the prediction market. This is a kind of undersold aspects of prediction markets, I think. And if you've read any of our work that Gabe has published or listened to the Twitter spaces that Gabe has done, you'll have heard a bit more about the information aggregation and information solicitation aspects of prediction markets. But this is something we believe in pretty strongly. In Delphi right now, you get that as machine learning models kind of do evals and benchmarks. This is interesting long term, but it's less interesting than the new version of Delphi that we're going to push out for Mainnet. And so you'll have seen we delayed the Mainnet back to April. There's a really good reason for this, which is the new version of Delphi is currently being built internally. That new version will allow anybody to make a prediction market. So instead of it being prediction markets over machine learning evals, the machine learning part shifts to being the settlement aspect of the market. And anybody in the world is able to define a market as the prompt for a model, the set of data sources that will be used to settle the market, and then they create that on chain. And crucially, Gensyn as a company does not control anything there. What you're doing is creating your own market on chain using our technology, using the kind of cost functions and prediction market tech that we've built behind the scenes. But once you've created it, it's your market. You're running that market. Anyone else in the world is able to then interact with that market and make predictions within the market, again, entirely on chain. You're not interacting with Gensyn as a company. You're interacting with a smart contract that somebody else has deployed based on tech and kind of infrastructure that we've built. When the market comes to the end state, the market creator can then settle the market, and they settle the market using an AI model. And so that prompt at the beginning that created the market and those set of data sources that were committed to at the beginning of the market are used and passed to the model, and the model is used to decide which way the kind of market settles. It could be a binary market where it's just a yes or no, or it could be multiple outcomes. You've probably seen these on Polymarket and Kalshi, those styles of markets. Those can be settled using these AI models. The market creator has a choice as well. They can do it fully reproducibly using our tech, or they can opt not to do it reproducibly. Market participant has the choice to trust a market creator if they're not doing it reproducibly, or if they are doing it reproducibly, they can go and check what the market creator has done when they've settled that market, so they can verify that this was actually done correctly, or maybe it wasn't, in which case they can kind of challenge the market creator and point out that they've done it incorrectly. And obviously from this, you get reputation systems and things like that can be built on top of this. So yeah, we think this is a lot more interesting, most likely to the people who are participating in prediction markets right now. We actually spoke to a lot of you in the community who had used Delphi and testnet, and also who were using the existing prediction market tech. And it came out quite strongly that a product like this would be more interesting at this stage. It also does information aggregation in a very similar way to how the existing version of Delphi does. Long term, and what might be more interesting to people, this creates this long tail of markets that can't be created on the current systems. So if you use like Polymarket right now, the markets that are on Polymarket are created by Polymarket. So if you wanted to make a market over something that's happening locally to you, maybe it's something that's interesting to you, it's interesting to your local community or friend group, you actually can't predict anything in that market. You can't have that market exist. You'd have to kind of lobby Polymarket to get them to add it to the platform. Using Gensyn and using Delphi, you can create that market. So you come, you put the initial liquidity in, you define the market, and you put it out there. You send the link to other people, and they can participate in the market. You, as the market creator in that situation, then earn fees from the market. So as volume goes through that market, you're able to earn from the kind of the predictions that other people are making. On the other side, if you're predicting in the market, same deal as you would have in any other prediction market. If you're correct, you're able to take some funds. You've kind of you've correctly predicted against other people who haven't correctly predicted, and so there's alpha available for you there. If you have information that you don't think other people have, you're able to come and trade it in that market directly. Long term, this incentivizes two really big things. The first thing is the discovery of interesting questions. Basically, these are kind of questions or like kind of events that might happen that are intrinsically interesting to the world, i.e. people care about the outcome of those questions. And so the market creator incentive basically means that people are incentivized to go and find things that they think other people will want to predict. The more interesting they are, the higher the volume is going to be, and the higher your kind of revenue as a market creator is going to be. So you're incentivized to find those most contrarian or interesting questions and pose them on the platform. This is a really interesting thing for AI, because if you think about the kind of future of AI as it progresses, teaching AI models kind of the basics is something we've been doing for a while. Those sort of like things that everybody knows, they're less interesting. They're just like basic principles. What becomes interesting is the things that actually are contentious in the world. So the questions that maybe we don't quite know what the answer is yet. It's not really obvious what the answer is. It's contentious amongst humans. And the market creation aspect of the Delphi markets incentivizes people to pose those questions directly out to this decentralized system. The second bit that's really interesting is the solicitation of information against those questions. So this idea that once a market is created, anybody who thinks they have alpha or kind of information that other people don't have about that market is incentivized to bring that information to the market and trade in the market. Because as and when they do that, they're able to kind of earn money based on that alpha that they have, that extra information. In doing it, they also inject that information into the market itself. And so in this way, the markets solicit information from everybody in the world. And when I say everybody, because of the way we build this, it's everybody. It's not just humans, it's also machines themselves. Agents can participate in these kinds of markets. And if they have alpha of some kind, they're incentivized to bring that alpha to the markets and participate with it. And so it pulls in information from absolutely everywhere via these local incentives and creates this kind of massive system of gathering data that in our view could get much, much, much larger than the centralized systems that you'll have seen in the AI world. So think about like Scale AI. Scale AI made enormous amounts of kind of money and value in basically forcing data and information to exist. They just went out and paid people directly to get that information. Delphi does a similar thing, but it doesn't do it by like brute forcing kind of payments to people for getting information. It creates a set of local incentives that incentivizes everyone in the world to just bring that information here because there is value there to be taken if they have the information. Long term, in our view, this becomes the kind of fuel for the future of AI training. I won't get too far into this because it's looking like beyond mainnet and into like what might happen in the future with Gensyn. And I kind of would like to leave a lot of that to people's imaginations. But if you look back at the things that we launched on testnet, you'll get a hint for what we care about going into the future. And RL Swarm is a kind of system where we proved out this horizontal training of machine learning models where you could get compute from all over the world and you could use these kind of embarrassingly parallel methods to train a model much more effectively than you could in a centralized way. That's great for connecting up compute as a resource, but you still need to connect up data and information if you want to get maximum scale. And Delphi actually does that, those kind of second two pieces. It sources that information, it sources that raw data from the wider world and brings it into the decentralized network. If theoretically somebody was to combine that with RL Swarm, you would potentially have the ability to build a model continually or a set of models that could get greater scale than any single company could possibly achieve. And eventually the incentive becomes so strong that those companies that are currently building the centralized models are actually incentivized to also participate in a system like this. When they realize the value of the alpha that they have or that their models have, this becomes a place where they can come and trade that alpha and they can directly monetize the information in the models or the intelligence of the models, the ability to find interesting questions, etc. So that's an overview of basically Delphi, how Re kind of feeds into Delphi, why we need that reproducible execution in the first place, and then post mainnet, what might theoretically happen and how you could take this into the future to turn it into a pretty large scale machine learning training system. There's a few different directions we could take this chat from here. I think we've had some questions already. So let me have a quick look at those questions and then we can go from there. But Xavier, feel free to flag anything in the chat if you just unmute and let me know and I'll explain further.
Absolutely. There's a question we'll get to from Ashiki shortly, and you and Harry are having a good conversation with him recently on X. But just based on what you were talking through then, there's a lot of new things being created and a lot of new things being pushed forward. How can you simplify what is new and what is groundbreaking in a few lines for people here?
Ooh, good question. Yeah, I guess the main thing is those two pieces that I mentioned. So we, like I said, we're launching three things essentially. The mainnet and the kind of token is one thing. In terms of novelty, there isn't kind of huge novelty there. We're not trying to sort of innovate on the design of the chain or anything like that. The novelty sits, at least for the launch, in those two things. It sits within Delphi itself, which is an application. So you can go and use it. It's a web app. You'll interact with it. If you've seen it on testnet, delphi.gensyn.ai, it will look similar to that, but obviously kind of progressed. There's a lot of work we're doing for the mainnet version. And then there's Re, which is the lower level machine learning kind of primitive for doing reproducible execution. This doesn't exist anywhere. This is proprietary to Gensyn. We've been building it for a long time. It's different to what other people might tell you, like using a trusted execution environment is kind of good enough for this, like a TEE. Our view is it isn't good enough. It achieves a kind of different, it solves a different problem, typically around privacy and only on the same device and constrained in terms of what you can execute within it, etc. Re allows you to do this across any device. Anyone could do it at home. Theoretically, you can rerun that execution. So this kind of doesn't exist elsewhere in the world. Just to go a click deeper on Re as well, Re isn't just useful for kind of blockchain use cases. It's very, very useful to be able to connect the kind of verifiability and the trust that you get from a blockchain with the execution of a machine learning model. And the only way you can do that is with reproducible execution. So as a kind of primary use case, it's there. But there are other use cases for reproducible execution within machine learning. Two kind of pretty big ones are one, something Thinking Machines spoke about in their first blog post, but this idea that reinforcement learning is only ever truly on policy if you do fully deterministic execution. And this gets a little bit probably too into the details for now of kind of like the machine learning training process. But the only way to kind of truly minimize KL divergence theoretically is to have absolutely deterministic execution. If you don't have that, then you're doing a kind of off policy, kind of hybrid on and off policy type of learning, which is effective, but it's theoretically less effective than doing true on policy learning. So when we get to that kind of final last mile of machine learning training, where we're trying to eke out the most effective reinforcement learning we can possibly get, you need things like this to do it to the best degree you possibly can. And this doesn't exist in kind of industry right now. The second piece that you get from reproducible execution is something that's probably less financially valuable, which is why people haven't tackled it so far, but it's valuable philosophically for sure, which is within the machine learning research space, we just don't have very good reproducibility of research. You'll read a lot of machine learning papers, and the kind of rigor of machine learning research is sort of a topic for another day, probably when we're not live, because it's an interesting topic within academia. But in any case, there's a lot of machine learning papers that get published that people just cannot reproduce. They can try, but there's always this kind of question of, can I not reproduce it because of just inherent stochasticity, or can I not reproduce it because actually a mistake was made, or actually somebody was misleading the kind of readers of this research, and the effects that they're describing and attributing to their kind of novel method actually is not true. It doesn't exist. And I think there are definitely areas within machine learning research where this is happening, and it generally just slows down humanity's progress. Like, it misleads us, which is net negative for progress. And so, whilst, like I said, there isn't huge financial value in this necessarily, there's enormous kind of philosophical research value in something like this. And we're kind of very keen to see how Re can solve some of these problems as well, not just those kind of trust and kind of verification blockchain problems that it's very good for solving. I think just jumping back to the question, I think there was also a question on how does increased usage translate into kind of the token itself. This I'd answer very, very simply in that you can have a kind of pretty simple method for implementing buybacks on that token. So if you think of Delphi, you've got the market creator taking a fee from every market that they create, the volume that goes through that market. A portion of that fee can go back to the protocol itself, and then that portion can be used to buy back and burn, like you would see from many protocols that are live now. You don't need to do anything crazy innovative to have that. You just need to have one thing that I think the crypto space lacks most of the time, which is like real revenue and like a product that people are using and driving things through. If you have that, you can implement this mechanism, and you can kind of have this translate back into that token. So that's the simplest case and the kind of most obvious place that you could do this, but there are more complex methods you can use as well, and we'll kind of talk about these further down the line and kind of closer to mainnet and after mainnet as we progress a bit further. But our kind of main goal here, especially on the product launches, is just to get the products out there and get people using them. That's what we care about. We want kind of the product in people's hands so that they can give us that feedback, they can use it from day one, and we can iterate from there. We want to build in public with it, essentially. And from April, that will be the kind of start of that building in public.
Fantastic. We've got one from Chegby on Delphi and whether it's a direct competitor to Polymarket.
That's a good question. I actually had this earlier today at the conference I'm at. You could view it in that way, in a kind of more accurate way. We do something quite different, which is something that Polymarket doesn't and can't do right now, allowing markets to be created by anyone. So, like I said at the beginning, the thing that we really care about is the long tail of markets. We care less about, not that we don't care, but we care less about these kind of big popular markets that like a centralized prediction market platform could create. And we care more about these sort of like random smaller markets that when added up lead to far greater information aggregation in our view than you get from just like one kind of big market that everybody's thinking about. An example I've been using about this whilst I'm at this conference is there's construction going on outside the hotel I'm in. There are local business owners who are probably very interested in when that construction is going to finish. They want to find out when that construction will finish. And so in the kind of traditional world, they would have to go out, they'd have to go and get the information themselves. They have to go and ask people. They're like trying to figure out what the kind of plan is for the construction. In the world of user created prediction markets, they can create a prediction market over, say, when will this construction finish, or will this construction finish in February? What this does is basically put a call out to the rest of the world to say, if you have information on this construction, there is money to be made in trading this market. And so come in and kind of put your prediction into this market. The local incentives are clear there. The local incentive of the market creator in that instance is actually information gain. It's not kind of the fees from the market. They want to know when the construction finishes because it has material impact on their business. The local incentive of the person participating in the market is to get some money. It's to use the alpha that they have to get money from this market. So everyone's happy at the local level. There doesn't need to be kind of some grand plan for them to combine their information together for something bigger. They're actually kind of satisfied by the execution of this system. That would never happen on Polymarket because Polymarket does not care about the construction that's happening outside this hotel. Like that's not something they're going to go and create a market about. It's something that a local business owner is going to create a market about, and it's going to be a relatively small market. If you add those up, there's a lot of places in the world that people want this information, and there's a lot of places in the world that people have information that they're willing to trade. And so creating a decentralized system that allows this to happen creates a level of scale that you just cannot get from an existing platform. So that's what we care about more than can we kind of have the most popular like presidential election market. That's not as interesting to us as can we have like literally every single other market created by people all over the world. We think that's far more interesting.
A function of democratizing information, in effect.
Yeah, through local incentives, crucially. So rather than saying like a popular thing, a popular topic at this conference actually is talking about kind of open source AI and what the sort of future is for it. Our view is the future of kind of open source in this way is actually creating systems of local incentives rather than trusting the like altruism of very large companies to like continue to kind of fund like open source AI and continue to open source their models, et cetera, et cetera. We believe more strongly in creating systems of local incentives like this that incentivize people to gather the resources that can be used to train these models. In doing so, you end up with the same kind of net effect, which is open source technology, open source models, open source applications, etc. But you've got it by giving every kind of individual, every company, every like person at home, actually a kind of direct, immediate incentive to provision that resource to that network. And what we're starting with here is information specifically out of the three resources we always talk about. Those three resources are compute, data, and information. Compute, we've talked a lot about in the past. It's just GPUs, basically, and kind of other processors. And so the ability to provision those in kind of exchange for financial reward is kind of a pretty obvious thing. It's you have direct payments. You can have a really simple, naive marketplace, but you can also have more complex kind of revenue shares and things like that in the future. This to us is something for further down the line. The more interesting and more constrained thing right now is that information piece. It's actually the real problem behind AI progress right now. The real problem isn't access to GPUs. It was a few years ago. And it will be again, no doubt. But right now, it's information. It's the labels that go on top of data. It's the kind of expert knowledge that a human has at a specific task. It's getting a human to run through a task and kind of record what they do and then use that for behavior cloning, for machine learning, etc. And we can gather that information using these local incentives in Delphi, and that can then be used in various different ways to train AI models. One of the sort of most naive ways is just like you've gathered a huge data set. You could theoretically sell access to that data set. We don't think that's that interesting. What we think is more interesting is in the future building training systems around this. And it doesn't need to be built by one company. It doesn't need to be built by a protocol necessarily. It could actually just emerge organically from the markets themselves. So as you see kind of in the early days, humans interacting with these markets most of the time, we think that will fall away to actually agents interacting with these markets. Maybe it's on behalf of a human, maybe it's on behalf of themselves. Either way, if they have information and they have alpha, they're incentivized to trade it because they can trade alpha for financial value, which they can then use however they want. They could use it to pay for their own compute. They could use it to pay for other data from somewhere else. They could use it to take actions in the real world. They could put bounties on chain and get humans to go and do things. There's tons of reasons why they want access to these assets, and they can get that by trading information in these markets. Once you have established that and you have agents participating in these crowdsourced and decentralized prediction markets, if you zoom out on that, you actually have an enormous training system, and you've snuck it in. You've had it without even realizing, because each of those agents is incentivized to make itself more intelligent because it's likely to get more value from the markets as it does that. And so it trains continually based on these markets and the information it sees in the markets, and it continues to improve. And then kind of you wake up one day and you realize you've created probably the most powerful kind of optimization system you could possibly create, which is a financial system. So you're using this sort of like stochastic optimizer, which is made of like capitalism, over the top of the kind of local like gradient-based optimization and things like that that is happening within each of the agents. So yeah, it's a way of kind of gradually creating a large optimization system without kind of deliberately or directly creating it. You allow it to emerge from a set of local incentives.
You've actually touched a little on a question I've seen pop up a few times, and not sure if you might want to elaborate or go into a little bit more detail on that, whether concentrating on prediction markets and the information benefits is a shift for Gensyn in terms of its vision of decentralized compute, or how that relates back.
Yeah, that's a good question. And like you say, yeah, I've touched on it, but I can be quite kind of direct here. It's not a shift in terms of vision. Our vision is to scale machine learning. It always has been. We've always talked about, if you go back to our light paper, even we talked about the 3 core resources under machine learning. The shift, there is a shift. The shift itself actually is, where do we start in terms of productizing this tech? So we've been building infrastructure for a long time that allows kind of these resources to be accessed programmatically, and it eliminates the like human world trust issues with access to resources, etc. How we actually take that to the world and get people using it was previously pitched as being the kind of compute network. That compute aspect is still very important. Something we've said a lot, I've said it on stage many times, is we don't believe in just building a naive compute marketplace. Just copying AWS and saying, hey, behind the scenes, there's decentralized compute here, is not very interesting. As a business, there's like a margin to be made there, but it's not a huge margin. And the centralized markets have actually closed that gap heavily anyway. And so it's a waste of time, in our opinion, to build out that technology when actually underneath what we care about is programmatic access to compute. Once you have programmatic access to compute, you can embed that within applications. You can embed it within agents. You can make it sovereign, etc. And that's how this really scales. In a way, you could distill this down to thinking, who is going to access compute in the near future? Is it going to be humans using like a point and click AWS style interface? Or is it actually going to be machine learning models themselves? And if they were going to do it, would they go to an AWS style kind of time-based marketplace? Or would they actually have a completely different way of doing it? We believe in the latter. They'll have a completely different way of doing it. They'll want to pay for task-based execution, and they'll want to do it in a way that doesn't require that front end. It doesn't require a lot of the things that humans require when they interact with these systems. We draw analogies back to the kind of shift to cloud back in the day. So we went from on-prem to executing somewhere in a remote data center. What the human is doing changed quite heavily. Like a human isn't kind of plugging things in anymore. They're just like using these web interfaces to select a remote GPU, etc. or a remote server. And then that moved again with serverless. And so we abstracted away a bunch of what the human was doing there. All the kind of sysadmin tasks sort of faded away, and a developer was just able to do their development work and then press one button, and all of that kind of sysadmin work gets automated away. The progress in machine learning with respect to access to compute is very similar. Like a lot is going to be abstracted away, but it will be abstracted away by the actions being done by an agent, by a machine learning model. And so they will be figuring out how to execute themselves, and they will use a very different system that's embedded within the execution of the machine learning itself. It's not this like marketplace that you have to go to that's kind of like in the web browser and you select 10 hours on an H100. Like a machine would not buy compute like that, in our view. So those were changes in the market and changes in our kind of view of how machine learning compute will specifically be traded in the future. At the same time, there was this growing belief within our team about the real constraints of machine learning right now, and that big piece around information being the biggest constraint. And again, I'll define information because I think this is probably the sort of fuzziest thing when we talk about these three core resources. The information is a kind of form of entropy. It's, if you imagine raw data as the kind of other resource, raw data could be something like an image, it could be an audio file, it could be a text file, it could be a video, it could be sensor data that's coming from an analog sensor and being converted to being digital. It's any kind of like raw signal that we record from the world. Information is the additional kind of informational value that is added to that data by an intelligent entity. Simplest example that I always go back to is categorizing an image or classifying what is in an image. So if I took a picture of a bird, for example, if I then as a human say that's a bird, I've just added information to that image. And that is predominantly what is used to train machine learning models, or what has been used to train machine learning models in the past era. That's supervised learning when you do that. So you get a human to label a bunch of images, and then you basically use the images and the labels to train a model to do that same labeling task. That's like a really simple kind of example of machine learning. It's supervised learning. There's still value in that. We still need to gather as much information as possible in that way to continue to train machine learning models. But there are other sources of information that get a bit more abstract and a bit more complex. Like when you get into kind of unsupervised learning, you have the information coming directly from the models themselves. Like clustering is adding information to sets of data. Semi-supervised learning, where you're doing a combination of the two. And then kind of more interestingly into reinforcement learning, where a model is able to generate its own information by taking actions within an environment and observing the outcome of those actions. That creates entropy or information. The point that we have right now with Delphi is that we think scaling access to information is the most important thing we could do to scale machine learning right now. The existing version of Delphi that you see on testnet does this in that kind of reinforcement learning way. It puts models into an arena and it gets them to take actions within that arena. And then it incentivizes humans to come along and predict what actions the models will take. In doing that, you're inserting kind of human preferences into the actions that the models are taking within a certain environment. And so you're essentially gathering up what a human thinks should happen in a certain scenario and putting that into the same kind of situation as the model exists in. You're then able to do a form of off-policy learning against human actions, which is really interesting. The second version that we have and that we will be shipping on Mainnet is just the general information aggregation piece, which is even more kind of abstract and zoomed out. It basically says it doesn't matter what the kind of prediction market is. It doesn't matter what the environment is. Anyone else can make it. They can construct it. We don't need to be opinionated about it. And then we let that information aggregation happen. We let the kind of people bring in information. We let agents bring in information. We let anybody train on it. It just exists in this huge decentralized system. Ultimately, this all goes towards the same goal, which is gathering information, gathering data, and gathering compute together to train models at a scale which is larger than any one company could possibly do on their own. And we do this by building that open source tech that anybody can participate in, anybody can interact with, anyone can have an on-chain identity. And again, when I say anyone, I mean humans, but I also mean machines themselves. Like they are kind of first-class citizens in this future as well. Like they're interacting just as any human is. They know the spec, they know what they can do on-chain, they know all the interactions they can make. They can just run just like a human. You won't actually even need to know whether the person you're trading against is a machine or a human. Like, why would you care? what you care about is whether you have alpha that they don't have, and whether you can kind of participate in that market in a way that's better than they can.
Thank you. That's actually touched on a couple of other questions I was reading through just now. You mentioned a little bit about users creating markets, users using the platform, users using the network. There have been two questions related to scale. How is the technology going to scale the network, Delphi, and what does that look like for people wanting to interact with it?
Yeah, I guess how is the technology going to scale? Yeah, basically by kind of the users that interact with it. So Delphi itself is a series of like contracts where you can interact with it and you can create your own contracts of markets. Obviously, it's all kind of packaged up in a way that means you don't have to like do all the kind of dirty work of actually creating these things. Like it is done via the contracts themselves. And then there's a front end where you can go and interact in a way where you can see the graphs, you can kind of have a nicer UX experience, etc. But there could be many front ends. There's kind of no reason why our front end needs to be the only front end. The point is there's a clear separation here. Those kind of contracts scale as far as our L2 can scale. So as long as we can keep kind of scaling the interactions on the network and the transaction kind of throughput stays high, then we can keep scaling in the same way you would see any Ethereum layer 2 be able to scale. The main kind of limiting factor is the people creating markets and people participating in markets. And we don't anticipate any kind of scaling limits for quite a while on those interactions. On the front end side, like every website that you would see, like obviously if there's huge load, you get issues. But then the beauty of it being decentralized is, again, you can have multiple front ends. So anybody here could create a front end to Delphi if they wanted to. And there's kind of nothing stopping you from doing that. If you want to create a front end over the set of contracts that we have, you're more than welcome to do that. We've seen people do this already on the existing version of Delphi, and there's been some pretty cool, like different views over the markets that have been created by people, different statistics generated by people as they assess the markets that have happened in the past. Everything's on chain, so as long as you have access to an indexer, you're able to go back and look at all the historical data as well. And there's no doubt enormous amounts of value and information existing in those historical markets that's just sort of there for everybody to interact with. It's almost a public good, I would say.
I'm thrilled you said that as a public good. That was one of my favourite pieces of the conversations with Gabe, hitting the idea that this information aggregation, as you were saying, actually becomes something entirely useful for everybody.
Totally. I think this is the big thing. The crucial thing here is that it's done via that set of local incentives rather than us coming and saying, oh, hey, like we should all band together and we should all, through kind of like altruism, decide that we're going to contribute to this system that will be kind of bigger than all of us. In reality, humans don't really kind of work like that. They do to an extent, but a better way of working is to find a set of incentives that work at the local level. So I am incentivized to come to this market. If I have information, I'm incentivized to trade because I get money from the information I have. And in doing that, I might not even know, but I've put my information into that system and that information is now available to everybody else. But I haven't had to do it in this like altruistic way where I'm sort of giving something up. I've done it out of choice because it's financially rational for me to do that. Like it makes sense. You can do this at every kind of part of the stack. You can do it on the compute, you can do it on the data, you can do it on the information. And in doing that, you create a far better system than I think the current model builders have. Because ultimately they are doing that. They're just doing it against your will. You don't really know. You're not a kind of first party in that transaction. It's just happening. And a lot of the time people are actually kind of unhappy about this. Like your information is being used to improve the models that you then pay them for access to. Your raw data is being gathered by those companies and it's being used to build something that they can sell back to you. That's not necessarily the best transaction for you to be in, but you don't have another choice. Using decentralized tech, you can have another choice. You can be a first party participant in that interaction from the very beginning. But crucially, it doesn't require you to have a worse experience necessarily. But this is the hard part. It's giving the kind of equivalent value experience to the individual user, but just changing the nature of the interaction to be more locally beneficial. This is better overall for consumers, but it's also better overall for the whole at scale, which is why it's so powerful. But it takes time to sort of take that existing system and create a better one. We've seen this, and this will probably get me on a rant somewhere else, so I'll close it pretty quickly. But we've seen this mostly in the financial space for crypto so far. Like crypto's set of local incentives and the way it allows an individual to participate and have a better experience in certain arenas than they would have in the traditional financial system is why it's so powerful. That can exist in other places, but it's very hard to build. And that's been the problem so far with crypto, that people see that promise, they believe in that vision, they believe it can happen outside of finance. But it's been really slow for it to actually happen. And there's only certain places that it makes sense to happen. Our view is that place very clearly is machine learning, and it very clearly is machine learning for one big reason, which is scale. Machine learning benefits from continued scale. It's something that's stayed true for the entire time we've kind of been researching machine learning. And decentralization gives you access to scale that you cannot possibly get in a centralized way. Like it's just straight up impossible. So it's necessary to get that scaling benefit, which is net good for the world. It also gives a better local experience to the individual, much like a lot of crypto does in the financial system for like remittance and things like that. The really obvious places where decentralized tech actually makes a core difference. But yeah, unfortunately, in the crypto space, lots of people have promised that that's true of areas where it just hasn't been true. And then you get kind of the dark side of the crypto world that we'll maybe not go into in this space.
Fair enough. That's fantastic, Ben. Thank you so much for that. Just a couple more to go. There have been a couple of questions as we've run through and we've been talking about networks and things as to how the network's going to be secured, whether people have opportunities to be validators, node runners, that kind of thing, or if there's a different mechanism in place.
Yep. So long term, yes. Short term, kind of fewer opportunities as we progressively decentralize, essentially. But yeah, there'll be opportunities to kind of run sequencers, etc., in the future. There'll also be opportunities to run hardware within the network. So you think about RL Swarm. RL Swarm isn't live right now because we got the information we needed from the testnet version of RL Swarm. We proved out the embarrassingly parallel training of reinforcement learning models. To go slightly deeper into that, basically, we made rollout generation embarrassingly parallel. And rollout generation within RL is basically figuring out the kind of actions of the model and what it does to the environment that they're in. It's allowing many, many, many different models to take those actions and then kind of assess the efficacy of the actions. That's basically a huge search process. So if you train a single model in a reinforcement learning way, it's basically just a kind of form of trial and error. It's trying out lots of different things and then it's testing those things. And if one of them works really well, then it's a great update for the model, but it has to just keep doing it to find the ones that work really well. If you actually take like 40,000 models and get them to do that in parallel, you very quickly get a kind of search process that happens a lot faster than it would have done in a linear way. And so that's just really valuable over decentralized technical rails. And so that's what we trialed in RL Swarm, and it was powerful. It worked really well. There are much more interesting things you can do with that same principle. So that principle of rollout generation or making kind of portions of the optimization embarrassingly parallel that we would like to trial in the future, but we'd like to do it more in keeping with how I've talked about Delphi here, which is with a system of local incentives. So rather than having to be kind of someone paying for like the whole system, somebody paying for all of these nodes to run this training, we would prefer there to be a reason why the individual running the compute themselves is actually benefiting. Maybe they're running their own model, which they can then use somewhere else. Maybe they're kind of accruing some on-chain reputation, which is valuable in some other way. We don't know exactly what those will be yet, but I think a system of local incentives makes a lot of sense in something like this. And then to go, again, one click deeper, and I'll kind of stop at this point. Actually, what you're doing there is something that we're quite familiar with in the machine learning space, which is using two combined methods of optimization to achieve greater scale than you would get with a single one. So the embarrassingly parallel rollout generation that we're doing is a form of kind of stochastic search. You're doing a very, very large search process, which its optimization function isn't gradient based, so it doesn't become linear. It's actually like kind of just It's very parallelizable. And then within that search, you've actually got at the local level gradient-based optimization, which is much more effective at having rapid updates, but it has to be quite linear and quite verticalized. There are lots of different stochastic optimization techniques than just the kind of random search essentially that you got in RL Swarm. And we would like to trial out these different stochastic optimizers over the top of the different nodes that could be run over the Gensyn network. And you could implement these on chain, you could implement them off chain, you can have kind of reputation and things on chain if you need it. There's tons of things that you can do there. But what we'll do as a company is be quite deliberate about the research that we do and discovering those local incentives for people to run nodes before we launch another version of RL Swarm. Might even have a different name, but the same principle will remain, which is having large-scale parallelizable optimizers existing across the horizontal nodes, and then kind of gradient-based, more linear optimizers existing within each node to get that like targeted update based on the outcome of the wider search. Like that's the kind of base principle that just exists under any kind of system like RL Swarm. So yeah, we're pretty excited about what can happen there, but it'll be a while before we kind of roll out anything ourselves along those lines. People are welcome to do it like from the community though. Like the code is open source for RL Swarm. If you haven't something interesting you'd like to launch, you absolutely can do on the Gensyn network. You could also tokenize it if you wanted to. There's kind of, you could try out some of those local incentive pieces. You could create your own kind of large scale machine learning model token, and you could give out portions of that token as individuals train bits of the model. Like there's a lot of stuff you could do. And we're very happy to chat with anyone who's interested in building a system like that. It's the reason we're a layer 2 is so that other people can launch these tokens and can build these things. There's a lot of stuff that can be done. And yeah, just talk to us if you're interested in building something like that.
Yes, please do. Really interested in getting people contributing to the entire ecosystem as it develops. I got one more for you from myself, but just quickly before we wrap up to that one, a quick run back to Delphi. There has been a couple of questions on the user-created markets and what, if anything, that costs or requires people to do.
Sure. So in user-created markets, anyone can come along. They can kind of run through the flow to create a market. And as I said, they are creating a kind of set of smart contracts or a smart contract for their market that exists on chain. Obviously, in doing that, you pay gas fees. So you're taking actions on chain, you're going to have to pay for the gas of those actions. If it's really busy, then your gas fees are going to be higher. All the things we're probably used to in the crypto space. Because we're a layer 2, obviously you don't have the congestion that you would have on Ethereum. There's not much else happening on our chain, at least in the kind of first instance. So you shouldn't be too congested from the beginning, and gas fees shouldn't be too high, but they exist for a good reason. They kind of make sure that the chain is able to continue processing transactions in the right way, etc. So they're there, and they're a kind of necessary piece of the system. The additional piece you need to do as a market creator is seed the initial liquidity of the market. One of the reasons, and this isn't the primary reason, but it's one of the reasons we're moving to this new version of Delphi that I've described, is we have a new construction of markets that we're going to use. In the past, we've talked a lot about the logarithmic market scoring rule, which is fundamentally an information aggregation system. It essentially is built for the market style that I described earlier with the construction. So this idea that there is somebody in the world who wants to access information. They want to know when that construction is going to finish, and they'll essentially willingly pay to stand up a market that other people will participate in, because they're essentially paying for the information that comes from the market. And the LMSR is very good at that, because it allows that initial market creator to seed the market with liquidity, which will pay off the kind of bets that or the trades that come in on either side of the market. It basically creates a smooth market, and it creates a counterparty to the people who are taking a position in the market. It allows it to be a highly liquid market without actually having a lot of volume necessarily, but you pay for that as the market creator. So we have that, we've built that, we've kind of got those contracts audited, we can launch those into the product. But for the newer version of Delphi, we don't want there to be that big liquidity requirement on market creators, because not every market creator is trying to solicit information. A lot of market creators actually just want to see volume in their market, and maybe they want the kind of revenue share on that volume. And so that's why we're moving to dynamic pari-mutuel for the first markets. This is a simpler construction in many ways. And essentially, it gives you the ability to seed the market with a small amount of liquidity, not a huge amount. Once you've seeded it with a small amount of liquidity, everybody who comes in adds to that kind of liquidity pool on the side that they take, a little bit like any kind of standard AMM that you would see in the trading world. Basically, all of these things are functionally AMMs. Automated market makers, but the LMSR provides the smooth kind of nice pricing function for the participants at the expense of the liquidity put up by the initial market creator. Dynamic pari-mutuel is a bit less smooth, but it doesn't require huge liquidity from the market creator in the beginning. So those liquidity requirements are relatively small. You have to seed it with something, otherwise you've got like weird numerical errors that will happen. Like you can't have like a zero position somewhere because it just screws everything up. But you don't necessarily have to seed it with a huge amount. Like it's kind of up to the market creator to an extent. So cost-wise, not a huge cost. It's basically just the gas fees and the initial liquidity to create the market. And then you're obviously welcome as a market creator to take positions in the market. Like we couldn't stop you even if we tried. Like it's kind of part of crypto is that you could just pretend to be a participant if you wanted to. So you have to build systems that acknowledge that that is a capability that market creator has, and then just allow them to do it anyway. Because if they could circumvent your system and do it a different way, you should generally just assume they're going to do it and allow them to do it. Otherwise, you're fighting a losing battle forever, and it just does not work. So yeah, market creators, not a huge cost, just gas fees and initial liquidity, and then obviously free to participate like any other participant.
Marvelous. Thank you so much, Ben. I know you're incredibly busy over there in Hong Kong at the moment, and I think that's given people a much deeper understanding of what's coming up and also the importance of it. If you do have a couple minutes, just one little request from me, because I know you have some deep thoughts about this. If you wanted to leave people with a few ideas around this whole intersection of blockchain, AI, the timing, everything that's happening right now, it's all coming together, and where Gensyn sits in the middle of that.
Absolutely. Yeah, I mean, now is a very interesting time. I have some views on a lot of the agentic stuff that's happening in the world. I think what's been happening really really kind of interesting recently is the stuff with OpenClaw, Maltbook, etc. Like the sort of AI agent frenzy has really like kicked off. I think this is interesting. I do think a lot of this is excitement and fear about a new technology that actually isn't going to play out in the way a lot of people say it does. And I'm probably contrarian in thinking this. I might even be contrarian within Gensyn in thinking in this way. But actually what I think is going to happen is we're going to get a kind of rising tide of these kind of fear-mongering and like excited posts and sort of people saying what's possible with these models. And then that's actually going to settle down and normalize into just an improvement in technology, frankly, because I think we've had this many times before. And ultimately, what will happen is the software that we all use and the products that we use will just get better. And we won't really think that much about why they're that much better. They just will have got better. Like the friction of using tech is just going to go down. That's what the kind of net impact is going to be on the average person. I think a lot of the kind of thing of like, oh, an agent is going to take your job and it's going to like do it better than you, etc., is not necessarily true. Like that's not how technology typically impacts the world. It typically impacts the world by like slightly changing the way we as humans do things and making it just much better to do those things. And if you happen to have expertise in that thing, you don't just become obsolete overnight. You just get better tooling and you can now do that thing better. And so I think we're going to see a huge amount of that. As it comes to blockchain and kind of crypto and how it relates to that world, this is a really nice moment for us because it ties really strongly into that thesis I mentioned earlier around the kind of value of like direct compute marketplaces. We've never believed in the value of that, which is why we haven't built one. We've had the opportunity to build a compute marketplace since 2021. We could have built one way back. We didn't believe that the way that humans interacted with compute, like booking time on GPUs back in 2021 or even now, made sense. It's not the kind of end state of these interactions. Our belief was that they would become more and more and more programmatic. We didn't necessarily know in what form that would take, but we did just believe it would become more programmatic. And basically, all of the kind of agentic world blowing up and these models starting to have more sovereignty and kind of be able to act on their own is the kind of culmination of that thesis. We're seeing why you need programmatic interaction with compute now, and it's because the models themselves need to be able to call the compute without having to go through a human. And so we've expected this to happen. We just didn't know what form it would take. And it's just nice to see it happening now. What's nice for Gensyn is we're very well positioned for that wave. We've been building all the infrastructure for that for the past few years. We hadn't productized it yet because we didn't like that marketplace idea. We can productize it now, which is what we're doing. And so you'll see us releasing these low-level primitives, which allow models to interact with compute. They allow people to aggregate information together, they allow people to bring data, they allow people to interact with models to kind of be sovereign, all of these things. We have all of this tech, we've been building it. And so this is the sort of, it's like the ideal of like a crypto infrastructure project, right? Or any infrastructure project. Like you make a bet on how the world is going to look in the future, and then you start building the infrastructure for that bet. You don't necessarily know what is going to kickstart the wave of like the world moving in that direction, but you just have this deep belief that it is going to move in that direction. And then when it happens, you can kind of smile to yourself because you're seeing it happen and you're ready for it, which is the position that we at Gensyn find ourselves in now. Like we're ready for it. That doesn't mean like the kind of push is over. We can sit back and just like, we've done it, like pat ourselves on the back. It means there's even more work to do now to make sure we catch the wave and we're building things right, we're productizing right, etc. But we're very well positioned to do that, which we're really pleased about. And it's obviously something that has come at a nice time for us. We launched the TG in April at the kind of time that this wave is happening, and we're ready to see what happens when we provide the tooling that we've been building for years to the world and have people use it and build these systems on top of it.
Excellent. Thanks so much, Ben. Always a pleasure having you up here, and I think that it's always very informative for people to get some deeper understanding. I'll let you go back to your completely blocked out schedule. Now, anybody with any further questions or wants to follow anything up a little more, just jump into the Discord and we'll catch up with you there.
Awesome. Thanks, Xavier. This was good fun. Feel free to tweet at me as well if you have questions. But you'll probably get a faster answer in the Discord, to be honest. But more than happy to answer things live on Twitter as well. But yeah, thank you everyone for listening. And we'll do these things more often in the future.
Excellent. Thanks again, everybody.